Of all the planets in the solar system, Venus is the one that should have been most like Earth, in the sense that it's the same size, formed at the same time, and for a period early in its history, it may have actually been, since there was liquid water on the surface, and temperatures that were not completely incompatible with life as we know it. What happened to it after that is one of the most extreme transformations any planet in our solar system has ever gone through. Because Venus didn't gradually become what it is, something triggered a chain of events that completely and permanently rewrote the planet. And the reason scientists find it so unsettling is because whatever started that chain was not as different from what Earth experiences every day as we would like it to be. Before getting into how it happened, we need to look at what Venus actually is right now, and it's something most people have never had properly described to them. The surface pressure on Venus is 90 times that of Earth, which means standing on the surface would feel like being 900 meters underwater, and that pressure alone would kill a human being instantly. The temperature sits at around 465 degrees Celsius on average, everywhere on the surface at all times. The atmosphere is so thick and so heavy that the sky from the surface isn't blue or black, it's a permanent dim orange, as the sun is barely visible through clouds made of acid that stretch 70 kilometers above the ground. Every probe we have ever sent to the surface has been destroyed. The longest anything has survived down there is just over 2 hours, and that was a Soviet spacecraft built specifically for Venus, reinforced to withstand conditions we knew would be extreme. So to believe that this planet used to have oceans is pretty disturbing. And yet the data keeps pointing in that direction, a Venus that was once nothing like what it is today. The evidence comes from the atmosphere itself, because when water evaporates from a planet's surface, it leaves a chemical fingerprint behind, and the fingerprint Venus has left suggests that at some point in its history there was a significant amount of water on the surface. Enough to have formed oceans that lasted potentially for billions of years. Venus and Earth were running parallel for a significant portion of their early history, and at some point that changed, and figuring out exactly when and exactly why is one of the most important questions in planetary science right now. The most supported theory for what broke that parallel is something that didn't require an asteroid or a catastrophic event, just heat and a feedback loop with no off switch. At some point, Venus received more heat than it could balance, and once that threshold was crossed, the atmosphere did the rest. Water vapor, carbon dioxide, gases that had been locked in the surface for billions of years, all of it ended up in the sky, and a thicker atmosphere on a planet already struggling with heat is not something that corrects itself. What we can't say with certainty is what actually triggered it, whether it was volcanic activity or something else entirely. Because whatever started it has been buried under billions of years of consequences, and Venus today gives us almost no way to read that far back. By the time the process was complete, the oceans were gone, the surface temperature had climbed to something no probe we have ever built could survive for more than a few hours, and the atmosphere had become so thick and so heavy that it created a pressure on the surface that has no comparison anywhere else in the inner solar system. The planet didn't explode. Nothing dramatic happened from the outside. It just slowly became completely and permanently incompatible with anything we would recognize as normal. And the most unsettling part is that the mechanism behind it is not unique to Venus. It is something planetary scientists think about when they look at Earth, too. What made it worse is that Venus was doing this to itself from below at the same time. Venus is one of the most volcanically active bodies in the solar system, covered in volcanic structures on a scale that dwarfs anything on Earth. And for most of its history, those volcanoes have been pumping sulfur dioxide directly into an atmosphere that was already trapping heat with nowhere for it to go. Sulfur dioxide in an atmosphere that hot and that pressurized reacts with the water vapor that was still present as the oceans were disappearing and produces acid, and that is where the clouds came from. Sulfuric acid droplets sitting 70 kilometers above a surface that nothing can survive. And those clouds now cover the entire planet, permanently, reflecting enough sunlight that Venus is the brightest object in the night sky after the moon. The volcanoes didn't start the process, but they fed it, and there is evidence suggesting that some of them are still active today, still adding to an atmosphere that has been out of control for so long. And that is what makes Venus more than just a hostile planet. It is the only real example we have of what a world like Earth looks like after it crosses a line it cannot come back from. Earth has a greenhouse effect too. It is actually what makes this planet livable. The atmosphere traps enough heat to keep the surface at a temperature that supports liquid water and life, and without it, Earth would be frozen. The difference between that and what happened to Venus is a matter of balance, and what Venus shows us is what happens when that balance breaks permanently. The reason this matters is because the feedback mechanism that transformed Venus is not something that requires a unique set of circumstances. It just requires enough heat to start evaporating water faster than the planet can compensate. And once that process reaches a certain point, the models we have suggest it becomes self-sustaining with no natural reversal. Venus crossed that point billions of years ago and has been on the wrong side of it ever since. We have sent missions to Venus specifically to understand that threshold, not because we think Earth is about to become Venus, but because understanding exactly where that line is and how close a planet can get to it without crossing is one of the most important things we can know. And Venus is the only place in the solar system where we can study what happens after it has already been crossed. The planet that gave us the clearest warning about what a world like ours can become is also the planet we know the least about, because nothing we build can survive long enough to tell us. Every mission we have sent to the surface has been a countdown from the moment of landing. As mentioned earlier, the Venera probes that the Soviet Union sent in the 1970s and 80s were the most successful attempts we have ever made, and the best of them lasted 127 minutes before the planet destroyed them. Since then, no spacecraft has successfully operated on the surface of Venus, and we have not seriously attempted it, because the engineering problem of surviving 465 degrees of heat and 90 atmospheres of pressure for long enough to do meaningful science is something we have not solved. What we know about the surface comes almost entirely from radar mapping done from orbit, which gives us the shape of the terrain, but almost nothing about the chemistry or the geology happening down there. That is starting to change. NASA's two missions that are currently in development specifically for Venus, Da Vinci, which will send a probe through the atmosphere collecting data on the way down, and Veritas, which will map the surface in far greater detail than anything we have done before. None of these will survive on the surface for long, but they will tell us more about Venus in the next decade than we have learned in the last 50 years. And the specific thing every one of them is trying to answer is the same question. Exactly when did Venus cross that line? And exactly how close to that line is Earth?